All right, have I given you enough time on the warm-up? Yes? Okay. So let's look at number 1. Since these exponents are being added, I can split them apart and make this 4 to the x times 4 squared. You agree with that? Okay, 4 squared is 16. So I get 16 times 4 to the x. We agree with that? What's wrong with my answer? F of x. Some of y'all have gotten sloppy with that kind of thing. Make sure it is a full equation. You got stuff on both sides of that equal sign. You at least have an equal sign, which is what some of us struggle with as well. Okay, we all good with that? All right, so then I have number 4. And this is being multiplied, so I can change that to 9 squared to the x power, which would give me 81 to the x power, and that would be k of x. Do we agree with that? All right, so let me ask you this. Could I have taken this one and instead maybe rewritten it like this and said, all right, well, I know that I can make 9 into 3 squared to the 2x power, which would give me k of x is equal to 3 to the 4x power. Now, do you see anywhere where I went wrong on anything? I don't think I did, so let's go with I didn't. So that makes this an equivalent form to this, which is an equivalent form to this. However, this is the only correct answer right now. Why? Do you know? Because in my instructions, I had this, okay? So if you start to do one of these, and you could go down either road to adjust it, right? They are still equivalent forms, 100% equivalent. But it's telling you to put it in this form with no horizontal stretch or compression, which means I shouldn't have that 4 up there. That's why this was the direction I really wanted to go in. You with me on that? Because we can go in both directions, and you need to be able to go in both directions for different reasons, but make sure you're paying attention to this stuff that they give you, because then you know what's allowed to be in there and what's not. Okay, does that help? We good? Okay, perfect. And if it was multiple choice, like I said, there's an infinite amount of answers. We could do all kinds of things here, but maybe these would be the 2 easiest to get to, but this is what we want. Also notice, even though it's said in this form, that doesn't mean make this y. This is still k of x. And if this was k of q, then there'd be a q up here, even though there's an x up here. Okay, it's just giving you the form. All right, what questions you got? We good? Great. Okay, so then grab your notes from yesterday. Let's see. This is where we are. Let's finish the calculator part, and then we'll go back to the beginning. Alrighty. So this says, after 50 deer were introduced to a large wooded area, so we got 50 deer were introduced, the population in the wooded area can be modeled by this exponential function. T represents the number of years since they were first introduced, and the population increases by 13% each year. Okay, that word increases, very important here. So it says find the values of A and B and use these values to write an expression for D of T. So let's do what they had us do on those first few questions where, so this says after deer were introduced. So that means when time is 0, so D of 0 is equal to A times B to the 0, which has to equal 50. You agree with that? So what's B to the 0? 1. So that means that A equals 50, because that's your initial amount. We kind of know that anyway, so you don't necessarily have to go through that little rigmarole, but I think it helps if you're not sure about what to do. So then let's use 1. So D of 1 is equal to A, which is 50, times B, which we don't know, to the first power. And we don't know what that value is. But if I wanted to find that value, right, if I'm going to increase by 13%, what do I have to multiply 50 by? 1.13. Good. So 13%, I have 13% more, which means it's not just 0.13. B would have to equal, so basically this would have to equal 50 times 1.13. So that means that B has to equal 1.13, right? That kind of helps you reason through what you want to multiply by. You with me on that? So now let's pay attention to this. This says this increases by 13%. What if it said it decreases by 13%? What would this number be? 0.87. You would subtract that from 1 instead of adding it. So instead of having 113%, we'd only have 87% because it would be less, 13% less. We good? All right. And then it says write an expression for d of t. So now that we have that, d of t in general, with the t's, not x's, is equal to A, which is 50, times B, which is 1.13, to the t power. So these little equations that they had us do on those first couple questions that seems kind of silly, you might still think it seems kind of silly, but I think putting the pieces in there and then thinking about, okay, what would I multiply this, what would I have to multiply 50 by, and what would that be? And that helps you get those. It helps you reason through your process instead of just your mind bouncing around to 1,000 different things. We good with that? Okay. So then it says, according to the model found in part A, what is the population of deer in the large wooded area after 6 years? Okay, so what are we looking for? D of 6. Okay. Now, I could just type this into the calculator and put 6 in the exponent. And I only have to do, I think, one of these, so I really could do that. But if I wanted D of 6 and D of 10 and D of 30 and D of 1,000 and D of this and D of that, I don't want to type that in a bazillion times, right? So where would I put that? The graph. So even though we wouldn't really have to on this one, we're going to, just so that you remember that that's a good place to put it. So get to the black screen by hitting home however many times you need to. 1 for new, then no. And we're going to add a calculator, and we're going to add a graph. And in the graph, we're going to do 50 times 1.13 to the x power. Should it be shocking that we can't see anything, right? Because our initial value is 50. Do we care that we can't see anything? No, because the graph isn't really doing much for us here. So I'm going to go back to my calculator screen, and I'm going to do F1 of what? 6. Now, can you have part of a deer? No. Like yes and no, but like no, when you're counting deer. Yeah. Yeah, we're counting live deer, I guess. So you're just counting, yeah. But I'm going to write down what I got out of my calculator, which was 104.0975. Okay. Now, even though I can't have part of a deer, and even though in this situation having a whole number might be okay, right? But, you know, is it 104? Is it 105? Because you can't have part of a deer or whatever. You don't have to overthink it. It's okay, unless it said, you know, to the nearest whole deer or something. We can just put that and it's fine. Don't overthink it. If when in doubt, put your decimals, okay? And that way you're not, you know, just put them down, you'll be fine. Everybody okay with that? All right, so then it says to find an equivalent expression for d of t where t is measured in months instead of years. Okay, so let me just write down what we had. We have d of t equals 50 times 1.13 to the t power. Right? And t is the number of years, so 1 year, 2 years, that's what we put in for t. This says we want it in the number of months instead. Well, how many months are in a year? 12, okay? So we're doing something with 12. I think we can all agree with that, right? My experience has been on questions like this. We know that there's 12 months in a year. And we also know that it should either be 12 times t or t divided by 12. But you got to wrap your mind around which one makes sense in what you're doing. If we're only 1 month in, is that more or less than a year? Less. How much of a year? 1/12, right? And if I have 2 months, that's 2/12. 3 months is 3/12, right? So the way I get that in my function here, instead of 1 full year, I need 1/12 of a year. My formula would have to be t divided by 12, or 1/12 times t. Okay, you okay with that? What questions you got? Okay. Just ask yourself, if I substitute this in, what's happening? We'll go from there. We good? All right, go back to the beginning. Let's talk about how we get all this stuff without regression equations. So this says sometimes data from exponential functions does not display a proportional growth pattern. It's due to a vertical translation of the function. However, if we add or subtract a constant, that's what makes the vertical translation, right? We can reveal a proportional growth pattern. Now, we're not really going to do that to reveal the growth pattern, but we are going to add or subtract a constant to the end. So that means we'd have something that looks like, actually I'll do a y. We would have like y equals a times b to the x plus k. Because k is your vertical shift, right? And so we got to figure out what that is. Well, when we look at a, and we looked at one of these the other day, it was just, we didn't write the equation, we just kind of looked at, hey, you know, when I look at this, if I put 13 over 7, whatever that is, it's not the same as 25 over 13, right? Because they don't reduce to be the same thing. So I don't see a proportional growth pattern here. So if I look at the common differences, 13 minus 7 is 6. 25 minus 13 is 12. 24. 48, right? Now, not linear, clearly. Not quadratic, because if it was quadratic, they'd be increasing by the same amount. Now, do we see a proportional change? Yes? So 12 divided by 6 is 2, 24 over 12 is 2, 48 over 24 is 2. So your R value, or in this case, that's really your B value, B here is equal to 2. Okay, so we got that much. We need A and K. So using this formula, I'm going to scroll a little bit so that people in the back can see a little bit better down here. But we're going to keep looking back up at this. And unfortunately, I probably didn't give you enough room. So I'm just telling you, if you got big handwriting, you might want to tone it down a little bit on this. We're going to write 2 equations. We're going to use this set of information and this set of information. Okay? So we have a y equals. We'll start with this first. Y equals. So 7 equals A, which I don't know, times B, which is 2, to the x power. Well, when y is 7, x is 0, plus k. Everybody with me? Understand where that came from? So then to use the next set of information, I'm going to have 13 equals A, which I don't know, times B, which is 2. What's my exponent here? 1 plus k. So what I have is a system of equations. I have 2 equations and 2 variables, and they're very simple. So if systems of equations makes your skin crawl when you hear that, this is not that at all. Let me simplify these a little bit. So 2 to the 0 power is what? 1. So this is just 7 equals A plus k. And over here, 13 equals 2A plus k. So there are my 2 little equations. And now I got to solve, now I can do substitution or elimination. I feel like most of us probably, substitution, if it's simple enough, is probably the way most of y'all would go. You can choose either equation, okay? And so let me just throw this out there about why I would choose the second one. It's because if I choose the first one and I solve for one, if I solved for k, or if I solved for a rather, then I'd have to substitute something in here and multiply it by 2, which is not that big of a deal. But if that was a weirder number, I'm just making more places to be a mistake. And then I have to think about which one I actually would have solved for. Do you notice I even said the wrong thing at the beginning? Here, if I just solve for k, it's going to just make my life a little bit easier. It's not wrong to do the other. I'm just telling you why I would make that decision. So I'm going to solve for k over here. So that means that 13 minus 2a equals k. So now that I have that, I'm going to substitute it in over here. And that'll give me 7 equals a plus, instead of k, that's 13 minus 2a. And then if I subtract the 13 over, I get negative 6 equals negative a. So a equals 6. Everybody with me? Ask me a question, Gavin. It's probably my back and forth that's lost you, I'm sure. Because when I subtracted 13 over, I got negative 6, and then I have a minus 2a. I just don't have a lot of room, so I skipped some steps. Yeah, I know. I thought we had plenty of room, and I was wrong. Over here, we're better because we have some extra room down here. All right, so I have a. What else do I need? K. I need k. So when since I have a, I can either go to this one or to this one to find k. I think that one's probably easier, right? If a is 6, what is k? 1. Everybody okay with that? I know it's all crammed in there. I'm sorry. Maybe I should have started with this one so you could see everything better. Then I'm going to write my function sideways. So f(x) equals a, which is 6, times b, which is 2, to the x power plus 1. Can y'all read sideways? If I can write sideways, you can read sideways. You can make it fit wherever. Everybody okay with that? What questions you got? Okay. I don't know why there's, oh, that's there from yesterday. That's why it's there. I was about to erase what we did. All right, let's look at B. So same thing on B here. We don't, 10 over 2 is 5, 34 over 10 is not 5, whatever it is, right? So we do our differences here. 10 minus 2 is 8. 34 minus 10 is 24. 106 minus 34 is 72. And then 216. Okay. So now do you see a pattern? Yes. And what is our B value? 3. So here B is equal to 3. All right, so I'm going to use, again, just the first 2 sets of points. So g of x, which is 2, is equal to a, which I don't know, times b, which is 3, to the 0 power plus k. Go ahead and write down what you think your second function or your second little equation is. And we'll make sure we agree. We agree with that one? All righty. So that means right here, if I simplify this first one, I get 2 equals a plus k, and 10 equals 3a plus k. So me personally, I would take the second one and solve for k. So I get 10 minus 3a equals k. Put it in over here, right? Go ahead and find a and k. I got a equals 4. You'll agree with that? Did you get k equals negative 2? All right, so then write your equation for g of x. What questions you got? We're good? All right, good deal. All right, on C, go ahead and find your B value. What does B equal? Is it negative 1/2? Positive 1/2. It's just positive, because if it was negative 1/2, the signs would alternate, right? So the fact that these were negative really didn't even matter. It's just 1/2. Okay. Now, write down your little equations. Once you double check your little equations with me, go ahead and finish this up. What questions do you have? Could I have made this 2 instead of 1/2? And if so, how would that change the x? It would be a negative x. Another way to do it. Which would be a reflection in the y. So think about that. When you have, so this right here is a decay, right? So we know it looks something like that. And if I made this 2 to the negative 1, it would be growth, but then it would be reflected in the y-axis, then it would still look the same. They all just look the same. Okay. What questions do you have? Anything? You're all good? What's your question? I multiplied both sides by 2 to get A. Anything else? All right, grab your assignment. We are going to look at the first one together. If you've already done it, that's great. Let's make sure we did it right, because I think literally everybody that asked me a question about it yesterday, something was not right in there, and I want to make sure that we all fully comprehend. So if you've already done it, great. If not, go ahead and put your data in. We're going to kind of work through this together. Hopefully you did do it and it is correct, but so I'm here add lists and spreadsheets. So it's going to take me, so if you've already done it, if you want to work on another one until we get to where we talk about it, that's totally fine. But if you haven't done it, do it right now. If you're still pushing buttons, that's totally fine. But is everybody okay getting to this part? Because I just like jumped ahead, assuming that we can all at least get there. And I remember, I don't know if said this in here yesterday or not, but if I want to write down 4 decimal places with this 583, I only see 3, but if I click on that cell, I see it down here, and I also see it, right, well, now that I've done that. I also see it right there. Oh, goodness. Okay, so if you need more decimal places. All right, so we all got that, yes? We're all good getting there. Okay, so what it asks us to do, let's read our question here. So it's talking about deaths and whatnot, but it says use the data in the table to create an exponential model. It's telling you in this form. So it's giving you the form. That doesn't mean that you have to use X and Y. This is in D of T and T. So what I get from my calculator is that D of T is equal to 583.1852 times 0.9363 to the T power. Okay, my T's have to match there. Any questions about how to get that from the calculator? All right, so here's where I want to make sure that you fully understand what I'm saying. And I'm going to show you and actually do for you what not to do. Because on B, it says, based on the exponential regression model found in part A, by the way, if this was wrong for whatever reason, okay? Let's say that you typed in 580 instead of 590 or whatever on some of these. The chances are pretty good your numbers here are going to be different, right? Which means you are going to not get the right answer in the end. Like, it's impossible. But if you use your wrong answer correctly, you could still get credit for the second part. Just throwing that out there, okay? Anyway, we're going to do this, and it says, approximately how many children under 5 years old are predicted to die from malaria in the year 2030? So am I looking for D of 2030? No. What am I looking for? D of 24, okay? So D of 24. So let me show you what not to do. First of all, I'm not going to do it by hand, that's for sure. But I'm going to go in here, I'm going to add a calculator, which is fine to do. But then 583.1852 times 0.9363 to the 24th power. 100% no. Why not? I need the exact numbers. I just typed decimals back in off my paper. Wrong, 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 wrong. Okay? You do not do that. Unless it was like 0.5 or something exact, the calculator has an infinite amount of numbers stored. Is there a chance that you do something where you write down the numbers, then you get the right answer in the end? Absolutely. It's possible, but you don't know when that's going to happen and when it's not, so you do not test that, right? So that is the wrong answer, I guarantee you. Even though what we wrote down on our paper is correct because we can't write down the infinite amount of numbers, right? Well, we have to use what's stored. We don't even have to go store it. It's already stored. Where did the calculator put this? F1, we told it to do that, right? You know when you choose your X values and then it says stored in F1? I don't even have to go look at a graph. I don't have to go graph it, like it is in F1. So instead, I want to do F1 of 24. So you can do that in your calculator right now. Boom. You have to be correct to 3 decimal places. That isn't anywhere near 3 decimal places. Not only that, if you're thinking, oh, well, it's not off that much. I mean, if we're talking about money, we're talking about what? 14 cents? Like, big deal, right? But does this represent 120 deaths? What does this represent? 120,000 deaths. So you're off by a whole lot more than 14 cents, right? Because you got to multiply that by 1,000. Now you got some options. When we write down our answer, you can multiply this by 1,000 if you want to. But again, sometimes we get off on what we're supposed to do with those numbers. So instead, we can just write down 120.3033 thousands of deaths. Don't just put deaths. If you put thousands of deaths, you're fine, and you don't have to adjust the number. But that makes that decimal mean a whole lot more then, right? What questions you got? Yes, ma'am. Deaths of children, right? Yeah. Predicted to die. So it's the number of deaths, thousands of deaths or thousands of children predicted to die. Yeah, that's fine. I know. It's scary, isn't it? But here's what the good news is, right? It's sad, but look how it's gone down. It's a good thing. But what's really scary is that since 2006, not like since 1906 or something. A little scary. All right, what questions we got? Anything? Okay. Do you understand how to use your decimals correctly? Right? The calculator is a tool, but again, it's not that you're allowed to, it's that you're required to, and you're required to know how to use it accurately and correctly. And that's what we're working on here. Because I don't want you to mess up a question, because if you do this, do you understand the question and what you're supposed to be doing? 100%, but you are not going to get credit for that answer. You get credit for this answer. Okay, we good? Perfect. All right, well then keep on working, and let me know if you have any questions.